Hi Wildcats, this is a review of the notes for mathematically determining the components of a two-dimensional vector. So the important thing to really think about when we think of the components here is that a vector has both a horizontal and a vertical component, or in other words, an x and a y component. And so if you think of like this is the path of a plane taking off, right? It takes off at some angle. Like, why does the plane go on this path? We see it go up and to the right. Like, this is the path that a plane would take. But why? Well, it's because it's going both sideways and vertically at the same time. And so this vector represents, or what we see is this resultant vector, represents the fact that it has both a horizontal and vertical component. And so if I told you the plane took off at 45 degrees above the ground, or 45 degrees above the ground at, I don't know, 50 meters per second, what is its speed horizontally and what is its speed vertically, or velocity vertically? And so we need to be able to have a way to solve for that. So let's look at that. And here's just another picture that represents that. Right here is 50 meters per second. This one's been solved. So 50 meters per second at an angle 60 degrees north of east has two components. Its horizontal velocity is 25 meters per second, so it's going sideways at 25 meters per second, and its vertical velocity is 43 meters per second. Those combined, those at the same time, going sideways and up at the same time, means that it has a velocity of 50 meters per second at 60 degrees north of east. All right, so how do we do that? Well, I figured we'd do an example problem. I guess I'm just into planes today, so we're sticking here. Here's a film truck. It's driven. We need it to go the right velocity so that it can shoot an image of this plane from right below. And so we'll need to know what velocity this truck has to have to match the velocity of the plane. But the plane is going not only horizontally, but also vertically at the same time. And so they tell us the resultant. They tell us that the plane is going 95 kilometers per hour at 20 degrees above the horizon. So that means only part of this 95 kilometers per hour is horizontal. We need to figure that out. So how do we do that? Well, first we want to break down the vector into its x and y components. So as we look at this here, we want to break it down and go, all right, what is its x component? Right here. And then what is its horizontal component? Or excuse me, vertical component. So right here. So this would be its velocity in the y direction, and then this would be its velocity in the x direction. And then determine, is this a right triangle? And in this case, it is a right triangle. Yay! And that means we can use Pythagorean theorem and our trigonometric functions to do it. So, something to take note of though. When they were giving us components, we would have these two, right? They would tell us the horizontal component and the vertical component, and so we'd have opposite and adjacent, and we could use those and tangent to find angle, but now we don't. In fact, all we have is the hypotenuse. So we're not going to be able to use tangent like we did before. We're going to have to use some other methods. So let's look at that. First, we are going to use cosine. So cosine is going to tell us the adjacent, right? Cosine of theta is adjacent over hypotenuse. And so in this case, our horizontal component is the adjacent component, because it's touching this angle, right? Adjacent means to touch. So these are touching or near each other. Whereas our y component is opposite. So we can't use Pythagorean theorem here because we don't know two sides, right? We can't use a squared plus b squared equals c squared because all we know is the hypotenuse. We just know c. So we can't solve if we have a and b missing. And so we can use cosine, though, to do it. Because do we know this angle? Yes, we do. It's 20 degrees. Do we know the hypotenuse? Yes, we do. It's 95 kilometers per hour. And we're looking for this adjacent component, or the x component of its speed. So we can solve for this one unknown. So what would that look like? Well, we can do, it's going to be sine of, cosine, right? So cosine of theta is equal to adjacent. Okay, but so now I think it's helpful to start putting these in not as adjacent and hypotenuse, but what they actually are. So really we would say cosine of the angle is equal to, well, what is adjacent? Adjacent is velocity in the x direction, or velocity of the truck, divided by the hypotenuse, and the hypotenuse is our resultant vector, so we call that r. So if I want Vx by itself, I just have to multiply both sides by r, the resultant, which they tell me this r is equal to 95 kilometers per hour. My r's cancel. Velocity in the x direction is r, so 95 kilometers per hour times the cosine of 20 degrees. Now, is your calculator in degrees? Mine is. And so I can just take the cosine of 20 degrees times 95, and I'm going to be left with velocity in the x direction is, I get 89.27, so 3 sig figs, we'll say 89.3 kilometers per hour. So this needs to go 89.3 kilometers per hour. So that tells us how fast this truck has to go to keep up with this plane. The other question is, how fast is the plane rising? And so since this is opposite, we would want to use sine, but all we're doing is the exact same thing, right? Nothing really changes there. So we would do sine of theta is equal to, now this is the plane's velocity in the y direction divided by r, right? This is still r, our hypotenuse. And so now I can solve for that. It's just going to multiply both sides by r, so we're just doing the same algebra that we did on the last one. And so the velocity in the y direction is equal to r times sine of theta. And that is, let's see, r is still 95 kilometers per hour. And now I end up with sine of 20 degrees. So if I take that, sine of 20 degrees times 95, I end up with 32.5. So this is going 32.5 kilometers per hour. And I want to point out that really, once we know the velocity of the truck, we've got two sides of the triangle, right? So previously, on the previous problem, part of this problem, we solved for v truck. So now I know the hypotenuse and I know this side of the triangle. You could also just use Pythagorean theorem to solve for this y component, right? Either or would work, because now we have two of the three sides of the triangle. So that works as well. The more information we have, the more options we have in terms of solving these problems. So hopefully that helps, just as you put together how to use the hypotenuse or the resultant vector to determine the individual components that make it up.